If you're a developer, you know the feeling. You're juggling, what, like 5 different terminals? You feel like you're constantly fighting your own workflow? Well, you're going to want to see this. We're about to dive into a powerful new system that might just fundamentally change how you build complex projects. All right, let's just start with a feeling we all know way too well, trying to manage a dozen different things at once. It's the classic developer's dilemma, right? How do you keep all the moving parts of a huge project in sync without it all just descending into pure chaos? I mean, are you sick of it? The constant alt-tabbing between terminal windows, manually kicking off scripts, and then trying to remember what's running where? It's a huge pain, and it can seriously slow down even the sharpest developers. And that's really the heart of the problem. As projects get bigger and more ambitious, your workflow can get messy, fast. What starts out organized can turn into a tangle of manual steps and just wasted time. And that is exactly the problem this nested Claude Code system was designed to solve. So what's the way out of this workflow mess? Well, a new approach is popping up, and it's promising a pretty radical shift in how we can handle all this complexity. The original creator actually calls it next-level vibe coding, which, you gotta admit, is a perfect description. The whole idea is to get past all the tedious manual grunt work of coding and into a flow state, where you're just focused on creating something powerful. So here it is, the star of the show, the Nested Claude Code system. At its core, this thing is a framework built to automate and, this is the key part, parallelize your workflow. That means it can run multiple tasks at the exact same time, all pulling together toward a single unified goal.
Okay, so how does it all work? What's happening under the hood? Let's pop it open and take a look at the core mechanics.
So picture a central controller that acts like an orchestra conductor. You just give it a high-level goal, like build me a web app, and it masterfully coordinates a whole team of workers. In this case, those workers are multiple Tmux terminals, which are basically these manageable virtual command line sessions. Each terminal gets its own part of the job to do, and they all execute in parallel, working together in perfect harmony. The actual workflow here is pretty slick. First, you just define your main objective, the big picture. You don't need to spell out every little step. Then that central controller intelligently plans out all the work and assigns tasks. So it might tell one terminal, hey, you set up the database, while another one starts firing up the web server. And finally, all those terminals just get to work, all at the same time, which, as you can imagine, dramatically cuts down on the total time. And these are the features that really make it tick. It allocates tasks dynamically, so it's always using resources efficiently. It plugs into super advanced AI models like Anthropic's Opus for really smart planning. You get to watch everything happen in real time through a nice interface. And because it's goal-oriented, you can finally stop micromanaging and just focus on what you actually want to build. Okay, so theory is one thing, but how does this system actually hold up in the real world? Let's check out a couple of seriously impressive demos that show what it can really do. The first demo is just visually stunning. It's a project to create a procedural galaxy in Three.js. Now think about that. It has to generate stars and planets, handle all the complex rendering, and build a user interface, all at the same time. This is where a system like this really flexes its muscles. And to handle this massive task, the system spun up 6 Tmux terminals, all working in parallel to build this amazing interactive galaxy.
And here's how it divvied up the work. One terminal was just focused on rendering, another was designing the UI, a third was busy generating all the objects in the galaxy, and the others were handling all the other coordinated tasks. This parallel approach is what results in a totally seamless final product, built way faster than you could ever do it manually.
Okay, next up, let's look at something a little more data-heavy. Visualizing the training process of a micro-GPT model. Now, if you're in the AI space, you know that getting real-time insights is absolutely critical. So how does the system tackle that? Well, for this job, the system smartly scaled to use 4 terminals, which really shows how flexible it is. And that highlights a super important point. It's not about using the most terminals, it's about using the right number for the task at hand. And here's the breakdown. The terminals all worked in concert to manage backend stuff, push live updates to charts, actually build the dashboard itself, and even generate sample data. The result? A living, breathing dashboard giving you incredible insights into the AI's training process, all built automatically. Now, this all sounds incredibly powerful, right? Almost magical. But it's important to keep a level head. So let's take a balanced look at the future of this system, both its amazing potential and some of the hurdles it's facing right now. So here's the trade-off. On one hand, the benefits are huge. I mean, less manual work, automated complex workflows, and a massive boost to your productivity. But on the other hand, there are some real challenges. Right now, it's really built for macOS, the initial setup can be pretty tough, and you definitely need some solid technical chops to get it all running smoothly. But, and this is a big but, there's a huge reason for optimism. The entire system is open source. And what that means is the community can jump in, they can adapt it for Windows or Linux, and they can work on making that setup process way simpler, which could solve its biggest challenges head on. Which brings us to a really big question, one that goes way beyond just this one system. Is this goal-oriented parallel processing approach, where we just define the what and let these automated systems figure out the how, is this the future of how all complex software is going to be built? It's a pretty powerful idea to chew on. Thanks for tuning in.